Moving right along, we've got a talk about resilience. Just as we experienced with Julius, sometimes things come up and resilience is all about just adapting to those and hopefully keeping going. So keeping going, we're going to bring up Amy to talk about how the future of DevOps is resilience engineering. Welcome, Amy.
And welcome again to Failover Conf. I'm Amy Tobey, and we got a lot to go through. But before we do that, usually when I do one of these talks, I get to walk up to the stage, and hang out and get the gear on and all that stuff. And during that time is when I bring myself and I calm myself down. And so I'll get to why we're going to do this. We're going to do a breathing exercise together. And there's a little bit of latency in this feed. So you may be doing it by yourself, but we're going to do 3 breaths. We're going to hold. We're going to take in for 6, hold for a beat or 2, and then out for 6. And if you want to, you can just sit there and watch me, and we'll come to this. All right? So here we go. Ready? There. Now I feel calmer. And the reason I did this is I wanted everybody to have this experience. I was hoping to do it in a room with all of you, but I hope this worked out. And so what that was is a very simplified pranayama. And pranayama is one of the 8 limbs of yoga, and it's one of the oldest parts of the yoga practice. And so a lot of Westerners tend to think of it as of what's called the asana, the posing and doing downward dog and all that stuff. But what pranayama is about controlling your breath. And what's really cool about this is if you saw Matt Stratton's talk this morning, he mentioned PTSD, post-traumatic stress disorder. And shortly after the Vietnam War, they were trying to deal with these soldiers who came back with PTSD. And they were trying to figure out, what can we do to help these people? And one of the things that they tried was yoga. And they found that it was super duper effective. People were making great progress on treating their PTSD. And I learned this from a book that's called The Body Keeps the Score. It's in my QA channel. I pinned a link to it. So I bring this up to talk about yoga as an ancient practice. It's been around for a long time. But in recent years, we now have the science to explain why those breathing exercises are so effective. And so we have this nerve that runs down the backs of our heads and into our heart and lungs and digestive system. And when we emerge from fight or flight and freeze, kind of the sympathetic response, what we enter is like a social reasoning part of our consciousness. And this is where we all should be right now. I hope you're all there. And why the breathing exercises tend to help us by bringing us into that part of our being. And so what happened is yoga figured this stuff out thousands of years ago. And then in 1994, Dr. Stephen Porges, using modern neuroscience imaging techniques and researched all of the body of research into PTSD and came up with this thing called Polyvagal Theory. So I'm not going to go too deep into it, but the idea is that the vagal system is in opposition to the sympathetic adrenal system that Matt mentioned this morning. And so all that is a fancy way to say is that the vagal system is how we get out of that fight or flight response and into a calmer state where we can do cognitive work. And so how does this relate to DevOps and resilience engineering, Amy? And so this is kind of, the ancient practice of DevOps. In internet years, DevOps is really old. It was 2008 or so, I started hearing about it. So it's a little more than a decade old. And I chose this chart because it kind of shows where I think DevOps is today. I really think that, we're in this spot where the people and process over tools part is kind of got back sidelined. And we have this plethora of amazing tools that we can use to build out all of these functions that we've discovered as part of DevOps. But there's still some work to do, right? There's still work for us to do to get into that place where we are, where we're working together and we're doing people and process over tools, and the tools are there to back us up. And I really believe that resilience engineering gives us the answers of how we go further. And so like how polyvagal theory and modern psychology and neuroscience have caught up to what yoga has known for centuries, the science of resilience engineering is a little more than 30 years old, but it brings that same science to DevOps and SRE and all of the work that we're doing to inform it so that we can go to the next level. So what I'm here to talk to you about today is I'm going to give you a very quick rundown of some big concepts from resilience engineering that you can start using tomorrow. So here we are. And so on this page, I'm showing two, again, these are pinned in the QA channel. The Field Guide to Understanding Human Error by Sidney Dekker is, I think, should be a cornerstone book in especially SRE and DevOps. I'll talk a little bit more about human error later, and you'll start to understand why it's in quotes there. And then the paper that I show here is also linked in the QA channel, and it's How Complex Systems Fail. It's 4 pages long, and I think if you read it, you'll recognize everything you see as things that you experience in your everyday work in DevOps or software engineering or SRE or whatever you're here for, right? Moving on. So what I'm going to do is I'm going to talk through these concepts in a little bit of depth, right? We have about 20 minutes to get through these, and some of these are incredibly deep topics. And what I want you to go away with is a lot of these resilience engineering introductions, I think, come with a lot of papers and name dropping and things like that. And apologies to all the folks who built up this wonderful body of literature. But what I'm going to do is charge through and give you the ideas that I hope you can start using immediately. So the first term I love to hear people throwing around, usually shortly after they learn it, is SocioTechnical System. And like many of these, if you sit down and think about it for just a few minutes, you're going to understand what it means. What is a socio-technical system? Socio-technical system is simply a system that has a social part and a technical part. And so in the picture here, I have Daft Punk. This is a socio-technical system. You know, there is the performance, the people up there on stage, just like I'm up here in a virtual stage right now, connected through the internet and a ton of technology to give this talk to you. So there's a social component. There's all of you over in the Slack having conversations and a good time and sitting and listening to me. And there's the technical part, which is all this stuff between you and me right now that's making all this work. It's amazing. And so really that's the whole idea in a nutshell, is like what I want people to do is to zoom out a little bit, right? Because a lot of us in technology tend to get really focused in on, you know, this is my framework, and this is my favorite language, and this is my favorite operating system. And that's great. But what we're finding is with DevOps especially, we need to pull out and figure out how the people and the technology come together in a better way. And this is where you can start to see the value of things that maybe aren't as clear when you're down in the weeds. Things like glue work, right? It's been a problem in our industry for a while that glue work is undervalued. But our work doesn't get done without that glue work. SRE work can't really happen without the glue work to bring teams in and sign them up for SLOs. So when you zoom out and you look at the socio-technical system, you get to see these processes that are not technical at all. They deal with technical things, but they exist outside of the technical system. They exist in the socio-technical system. I wanted to move this one later, but we'll start with common ground, and we'll come back around to joint cognitive systems. So a lot of this stuff is from cognitive systems theory. And when you dig into the resilience engineering body of papers and things, a lot of it is from cognitive sciences. And so common ground is one of these things that's really useful. And I like to think of it in terms of playing in combo bands, jazz combo bands. And so one of the remarkable things about combo bands is a lot of times you can show up to a gig or jam session, and there's a bassist and a pianist and a drummer there. And you show up and you say, hey, let's do A train, and we'll do it in let's do it in G, right? I'm not sure if that's a key, that I haven't done it in a while, but in that short amount of communication, you've just communicated a whole bunch of stuff, right? Because you have a ton of common ground. Everybody in the band knows what you mean when you said, let's do A train. Everybody knows that chart. They probably played it a million times. And when you say what key is it in, you've just communicated a huge amount of data, right? And they know about, like, the bass player knows how to put a bass line together, the piano player knows how to do changes, and the drummer, because he knows the tune, can put down a beat. But maybe you'll tell the drummer and say, like, I want, let's do it over a salsa beat just for fun. I don't know if that's going to work, but it's the kind of thing that tends to happen. And it's all basically relies on common ground. And so I picked Miles Davis here because that was one of his deals, is he did a lot of that. And so I'll come back to this a little bit in just a moment. So next up is cognitive capacity. And this is probably the one that the people around me are most tired of me saying all the time. And so the way I like to describe this is to start with something from the disabled community called spoon theory. And so I'm just going to borrow this for a second, and then I'm going to give you cognitive capacity as something that the rest of us should be using to talk about a very similar kind of experience. And so spoon theory is basically, when I woke up this morning, and I got ready to walk out my front door, which is my bedroom door now because I'm not really leaving the house, but the idea being was I woke up and I kind of sat there and thought, I got to get up and get ready for the thing today. And so I roll out of bed and I stumble into my bathroom, I brush my teeth, I do my routine. And by the time I step out of my front door, I'm still feeling pretty good. I haven't burned a lot of my day's energy. But if I had a handicap, a disability, something that made life harder. So if I needed a mobility device to get from my bed to the bathroom where I could start to do my routine, all of a sudden now the cost of me getting ready to walk out my front door has gone up. I have less energy to offer to the work that needs to be done. And so cognitive capacity is very similar. It's talking about our ability for our minds to grasp with these complex topics that we work with, and how much of that do we have? How much thinky juice do we have? To put it in vernacular, is that you've experienced this. So at 4 o'clock in the morning, you get paged, and the web service is down, and oh my gosh, you got to get in and take care of it. But you know how it is, right? You wake up in the morning and you go, oh God, what is that? And you start to wake up, but you don't really have a lot of cognitive capacity unless it's like the whole site is down. Maybe you get that shot of adrenaline, but that's still not really getting you where you need to be, right? Because of what we talked about earlier with being in a safe and calm place for maximum cognitive ability. And so the idea here being is when we think through what cognitive capacity is available to people in the situations they're dealing with, this allows us to design things in a way that maximizes our chances of success. And so, for example, in the on-call case, when we write run books, if we think about us waking up at 4 o'clock in the morning after, maybe taking care of our kids late into the night, and now we roll in and we have to read a run book, that thing should be written for kind of, us not at our best. And that's the kind of thing that where cognitive capacity and talking about it more frequently and using it as a lens to look at the work we do can improve that socio-technical bond, right? The technical systems will be more ergonomic for the humans. The humans will have a better understanding of what they're dealing with. And what you'll start to see as we go through a couple more of these, that these things overlap like crazy. And that's okay. So next up is joint cognitive systems. And so a joint cognitive system is very simply a system that, maybe not very simply, because there's not a lot simple about these, is when you have an interface that a human uses, or you have two agents that have to work together, and they need to be mutually interpredictable. And when I say mutually interpredictable, if I'm trying to guess, if I go to my CI/CD pipeline and I go build the stuff, I'm predicting that it's going to go off and grab the master branch, and it's going to go and build it with a container with a good compiler in it, and then it's going to spit out an image to S3, and then eventually that's going to get sucked down to my production systems. There's a lot of prediction happening there. And if that system breaks down and then doesn't deliver the asset, now all of a sudden there's a breakdown in it. And so there isn't this ability. My prediction has failed. And so when we think about things through this lens, and so I think DevOps especially deals a lot in joint cognitive systems. Almost everything we do as DevOps engineers is dealing with joint cognitive systems. And so the other part that I kind of skipped over with common ground, because common ground and joint cognitive systems go together really well, right? If you go and Google these, you're going to find that they both come up in the same papers. And so maybe I shouldn't have broken them out on their own. But there's this sub-problem that I think everybody will recognize is called fundamental common ground breakdown. And so it goes like this. I'm going to borrow a couple of assistants here. We have person A and person B. So person A here thinks that person B knows something. Person B doesn't know this. He doesn't even know that he's supposed to know. And as a result, doesn't ask any questions. It's fine. And this lack of request gets interpreted by person A as person B having the knowledge requested. And this leads to all kinds of situations that we've run into in dealing with production systems and even interpersonal things. When we think about it in terms of fundamental common ground breakdown, we all suddenly step past and saying, Amy screwed up and didn't tell me the thing that I was supposed to know, and saying, we've stepped on a common problem, and now we can work through it structurally. And so this is a really useful tool, not just in dealing with technology, but dealing with people. And then it also happens between technology and people. Here, I would also like to mention very briefly, and you can go look this up. It's called, the easiest way to find it is Google, is the varieties of human work. And there's this thing, I'll probably talk about this at SRECon, called work is done. And so what you can do is, in joint cognitive systems, this makes more sense because you start saying, what is the work that's actually done? So me as an SRE, the work I actually do on a day-to-day basis is, I log into terminals and I do stuff, and I write code that goes into a CI system. And I go off and I do meetings to manage incident proposals. That's the work that I actually do. There's the work as imagined, what my boss might think I do, or in my job description. There's work as prescribed, what I'm told to do, right? What is the procedures I'm supposed to follow? Most of us in tech don't deal with this quite as strictly as maybe in places with more like locked-in procedures. And then work is disclosed, which is what I admit to you. Do I even remember to admit all the work that I do, or to disclose it? Or do I hide things, because there's an atmosphere of fear, and admitting that I did something wrong might get me fired, or maybe I just believe that. And so using this tool to examine the work is really important to DevOps folks, because a lot of what we do is about enabling other people's work. And the better we understand those other people's work, the better we can design systems to support it. Adaptive capacity is the next one. And so this really comes to the core resilience engineering that I forgot to say earlier. And so if we want to define resilience engineering very clearly, it's our ability to act, especially in emergent conditions that maybe we didn't plan for, right? So adaptive capacity is kind of like a way to think about it as a quantity, right? We can't really measure this because it's a very human thing to think about. But adaptive capacity is things like improvising, right? So in a musical situation, I can, because I'm given some changes in a background chart, with a beat, I can sit and I can be adaptive. I can create things, and I can do communication with my rhythm section and create a work of art on the fly through adaptive behavior. It's when we go off script, or when the run book, it doesn't cover the situation that you're in, and you go, oh crap, I don't have a run book for this. Now I've got to go in and figure out what to do in a live production system. That's adaptive. And so we've seen a lot of this in our society today. This is super critical to everything that we're doing. We have people trying to figure out how to make personal protection equipment from stuff that's readily available. That is extremely adaptive behavior. And so when we think about this as its own thing, one of the two things I really love is when we go back to the on-call example. When we're on call, what our companies want from us is adaptive behavior. And this is a great way to do things like filter alerts. So when you look at an alert and you say, hey, this alert goes off, and we run the same run book, and when we get to the end, nothing ever changes. That should be automated, right? That's how we choose the automation, because it's not adaptive. We should reserve our cognitive capacity, our adaptive capacity, for the things that humans do best, which is reacting to things that are unexpected. Computers are great at dealing with things that are expected. That's the happy case. It's when things go sideways or get interesting that we as humans need to step in and exhibit adaptive capacity. So it gets a little less soundbitey from here. So coordinated response is something I just want to talk about briefly. One of the things that's happening in our world is things are getting more complex. When I started my career and did my first DevOps work in like 2004-ish, I had, I think, 4 Apache servers running mod Perl, and I had, I think, a dozen developers, that were just writing simple Perl, and I had MySQL in the backend, or I think it was Oracle actually, and Linux. That was it. I mean, the load balancer was a Linux HA box too. I mean, there was just not much to it. You could take the whole thing out and stack it on this desk, and it wouldn't even reach the camera. And so the complexity was much lower than today when we talk about complexity, like the talk just before mine, or a couple of them ago when we were talking about serverless, right? Serverless technology is incredibly complex and cool, but it's out there beyond our ability to really understand what's happening under the hood. And so when things go sideways, we're dealing with all this complexity, the importance of us coordinating our behavior becomes more and more critical, because we need to be able to have people focus deeply into their areas of expertise. We need to be able to keep our MTTRs shorter. And so this is why we have things becoming more popular, like incident command. And so again, resilience engineering is informing how we build the future of our careers and our companies by providing the reasoning and the critical research that tells us why certain things work. As I mentioned earlier, when I showed Sidney Decker's book cover, there's no such thing as human error. So if there's nothing else I think you take from here, let's forget if anytime you hear human error, you stop the meeting, stop the conversation, and say stop. Human error, maybe you shouldn't stop. Human error just isn't a thing. When you arrive at human error and say Amy messed up and pushed the wrong button, the question isn't like, did Amy push the wrong button? It is, how did we reach the point where Amy was pushed the wrong button? Was she tired? We go back to cognitive capacity and say, did she get a good night's sleep last night? Is there a lot of stress in her life, where she doesn't have the ability or the cognitive capacity available to be able to make good decisions? Was the button designed wrong? Are they too close together and it's easy to mash the wrong one? Are they labeled wrong? So that's why I invite you, when you run into human error, to keep going, to not stop at the human and go beyond into the broader socio-technical system and discover how this all came to be. Similarly, root cause is not a thing. Somebody mentioned this earlier. I think it was Matt Stratton. I'm betting that probably Paul will mention it later at the closing today. But we're going to keep saying this, and it's okay for you to say root cause sometimes, right? Because sometimes what you really mean is a shorthand to say the most specific thing we could identify that went wrong, right? That's really what I think you're saying, because there's never just one thing that went wrong. Just like, this is a banyan tree in the image, right? There really are no end terminals in the roots. They go everywhere, and branches grow new roots down. And so when you find what you call a root cause, there's usually more branches off from that. And we should follow those. And as our ability to look at how our systems perform, as we build maturity in that space, we'll keep going deeper and going more branches out from what we think might have called a root cause, to say what in the environment and what are the situations that put us in this place where this one component could fail and cause this this cascading event. And I'm not going to say you shouldn't learn from failure. What I am going to say is that you shouldn't only learn from failure. I first heard it from Dave Hahn when he said, you can't really build a good marriage, a healthy marriage, from studying divorce. And this I feel like expresses this in a better way than pretty much anything else I've tried, is to say you have to look at the 99.9% of things that go right. If you have an SLA of 99.9% and you're meeting it, that means 99.9% of the time everything is going according to plan. And if we don't understand why things go according to plan, then we probably won't be able to find the right solutions when things go wrong. And so we really need to spend more time not just on what's bad, but looking at the things that are successful in our businesses. The people, when we have a 10x engineer, right, and we say, wow, look, they're really cranking out a ton of code. What is going on there? Like, how is that person able to do it? Very often you look and it's privileged. But we should reveal that, and we should understand it so that we can build our organizations to be more resilient. So that was a lot of content in just a few minutes. I'm going to do a quick review, and let's see how this goes. We have socio-technical systems. This is where the people and the technology come together to create a larger system. And when we zoom out a little bit, we start to see how the interactions between components and people and user interfaces and backend systems, how all these kind of invisible things like our agile process and our retrospective process, and how we process incidents to feed into product pipelines, how all this comes together and works together instead of just focusing myopically on the technological problem in front of us. In doing so, we create an increased base of common ground about talking about our systems and understanding our systems in better ways. And then when we run into things like fundamental common ground breakdown, where this guy, well, it's backwards, doesn't know what he doesn't know what he needs to know, it's not his fault, right? We need to move past that. And so by understanding these patterns and these things that happen so frequently when we're under stress or when we're dealing with all this complexity, we can move further faster. We talked about cognitive capacity, which is our ability to be able to bring our full selves and our minds to bear at whatever problem we need to solve. And our organization pays us to do this. And so we have to be aware of what we have available. And I feel like this is what leads into building things like more humane work and more humane on-call schedules, building better user interfaces that don't consume quite as much cognitive capacity to do simple things. Joint cognitive systems, again, backing up to those previous two, is when we really think about the two systems together. This is like socio-technical system, but we zoom in and look closer at when we have these complex interactions, what the interpredictability between the agents in the system are. And then we have adaptive capacity, which is our ability to do things we haven't done before, to meet emergent conditions happening like, I don't know, a global pandemic, and be able to adapt very quickly and do new things that we haven't done before to both survive and to thrive. There's an increased need for coordinated response. We're not going to be able to keep building these layers and layers and layers of complexity that we've been building for the last 20 years or 30 or 40, depending on where you start counting. Let's start with Unix, 1970, right? So, but still, we've built a ton of complexity since then. And there's no human alive that can really comprehend all of it. Each of us comprehends a different slice of that stack. Even when we're full stack, we still have a narrow slice. And so we need to be more aware of how we respond so that we can put people in a position where they succeed and they can reach solutions faster. And they can meter out their cognitive capacity and direct it in a more coordinated way. Human error is not a thing. I don't want to hear it anymore. When I see that there was a mistake that was made by a human, you need to go further and look at that dang button. Look past the button. Look at the labels. Look at everything around in the environment of that mistake and understand why. We talked about how root cause is a thing. I think everybody gets this. There's no root cause. We might identify something that feels like a root cause, and we may still need to use that language because it's so common in the world. But we know when we reach it, we need to go looking for the contributing factors, all of the things in the causal graph around that event that fed into it and made it possible. And that's where we can really learn the interesting things about our systems that help us build more resilience and more robustness. And finally, learning from failure, which we should still do. This is why we do big incident reports, but we should also do the ones on, say, near misses, right? Talked with Lauren Hochstein, and he did the oops thing at Netflix, right? Where people had near misses or just little things that didn't affect the main KPIs, and looked deeper into them and found ways to draw additional features and robustness out of those incidents. But also we should look at that 99% of success and understand why we are successful at the things that we succeed at. And with that, I'm Amy Tobey. I work for Blameless. We make incident tooling and all of the stuff, some of the stuff I talked about. And I'm on Twitter as Miss Amy Tobey. I will be in the QA Amy Tobey channel for the next hour or so. And thank you very much. Have a great afternoon.